Welcome to my YouTube channel Knowledge Share. In this video, I will be sharing about wiring, grounding, and safety in electrical engineering. To introduce myself, I am Dr. C. Uday Shankar, Associate Professor in EEE Department, as well as Senior Innovator in Innovation Hub. So let's go into the topic, today's topic. So here in this video, I will be sharing about wiring, grounding, and safety. So in this, I will be dealing about what are the general rules that will be followed, and what are the materials and accessories, and what are the types of wiring, and as well what are the wiring layouts of any residential building, as well as what is the importance of grounding, what are the types of grounding, and along with that I will be handling about the safety and what are the causes of accidents and how to prevent from the accidents, and as well using DT concept, that is design thinking concept, how we can design the residential wiring. So these are all the topics which I am going to cover today. So here let's go on with what are the wiring materials and accessories that are used by an electrical engineer, or normally what we'll be using in any during wiring. Okay. So these are all there in the syllabus, so I will be covering one by one. So normally the first one is switch. Okay. So what do you mean by switch? A switch is nothing but which is used to make or break any electrical circuit, and the main important parameter is it has to contact firmly. That's the very important parameter for any switch. And also if there is any abnormal conditions, okay, it has to regain its rigidity, and it has to be in alignment between the switch blades and contacts within a fraction of centimeter. Okay. So there are many types of switches, like surface switch is there, flush switch is there, pull switch is there, rotary snap switch is there. Anyway, we will be discussing about in detail. I will be showing you different pictures of in a real time pictures I will be showing. So now we will just see what is a surface switch. A surface switch is nothing but which is mounted on a for example, it is mounted directly. Okay, it is mounted directly, or it is fixed over the surface of the wall. So such type of switches, it will be projecting out of the surface of the wall, and there are two types. One is the single way switch and the other one is the two-way switch, and it is used for wiring circuits. For example, if you take a two-way switch, it is used for wiring the circuits which has to be controlled from two different points independently. So for example, normally we'll be using in our bedrooms, where the two-way switch will be, one switch will be near our switch, the other switch will be at the entrance. So that is the two-way switch. Okay. So anyway, we'll be seeing in detail with some pictures in the forthcoming video. Okay. So what do you mean by flush switch? A flush switch is nothing but it is fixed with the wall, and it does not project out. Actually, it will not project out. So these switches are also classified as single way and two way switches as well. Okay. And what do you mean by pull switches? So pull switches, these are also called as ceiling switches. So for example, the pull switches are also fixed on the ceiling actually, whereas that is, the switch has a strong mechanical action, and it is usually operated with a single pull on cord for on and off. So we will be using a cord to switch on and off the pull switches or ceiling switches. So then we will be having the fourth type, that is called as a rotary snap switches. So what do you mean by rotary snap switches? The rotary switch consists of an insulated handle, okay, to which some fixed blades will be there. Okay, some blades will be fixed actually, and these blades will be moving in steps by moving the handle actually, and it will make the contacts with the terminals which is connected to the wires. Okay, So like that, the rotary switch will be that is, it is called as cam or spring. It is controlled by means of cam or spring actually. The handle is moved by quarter turn by the blade, and it is released and moves over quickly. Okay, so these switches are available as well in single as well as a two-way patterns. Then we will be moving on to the push button switches. So what do you mean by push button switch? So this type of switch consists of one blade only. Okay, that is a very important thing, and this blade is given rocking action by pressing by using the press button, and its movement is controlled by cam and spring. Okay, so thus the blade opens and closes with quick motion, and this type of switch is called as the push button. Anyway, we will be seeing the diagrams in the forthcoming video. Okay, so I will be just showing so that you will be having more clarity. So what do you mean by ironclad or watertight switches? So such switches are made up of the cast iron actually. Okay, it will be having robust construction. That's the main advantage of this. Okay, so now we have discussed about switches and its type, and we will move on to lamp holders. So what do you mean by lamp holders? So lamp holder is nothing but which is used to hold the lamp for lighting purposes. There are different types of lamp holders, like pendant holder, batten holder, and as well as screw lamp holders and fluorescent lamp holders and starter holders. Okay, so these are the different types. So let's go into the lamp holder adapter. So it is nothing but it is used for tapping temporary power for small portable electrical appliances from lamp holders. So such practice is not advised actually. Okay, the next is ceiling roses. So these are used to provide tapping to lamp holder through a flexible wire or connection to the fluorescent tube or a ceiling fan. Then what do you mean by mounting blocks? So these are nothing but wooden round blocks. So they are used in conjunction with ceiling roses, battened lamp holders, as well as surface switches, ceiling switches, etc. So like that you have socket outlets, and also plugs are there. Okay, so what do you mean by plug? So these are used for tapping power from power outlets. So this is called as plug. So what do you mean by so there are main switch is there, distribution fuse board is there. So these are the different things which are used in distributing the electrical energy to various domestic appliances. Okay, so what are the different tools that are used? For example, we are all aware of this, but anyway, since it is there in the syllabus, I have to cover this. So the tools are nothing but there are two types of screwdrivers. So one is called as a thin blade. So this is called as thin blade, and one is the other one is the square blade type. So square blade is nothing but it will be having a star in the end, and star blade. Okay, it is also called as a star blade and as well. Okay, then hammer. So we will be using hammer. So there are two types of hammer. One is called as the ball pen type. So you can see that ball pen type is there. The other one is the claw hammer. So claw hammer will be also used to remove the nails which are present in the wooden boards and other things, right? Then next is pliers. So what do you mean by pliers? So there are four types of pliers. So first one is the side cutting plier, diagonal cutting plier, long nose plier, and as well slip joint plier. So these are the different types of pliers actually. And there are different types of knives that are used. So pocket knife is there, hand drill is there, chisel is there, wood saw is there, hand saw is there, and as well center punch is there. Okay, and next one is vise. So you know what is vise? So vise is used to tighten any bolts or to even loosen any bolts, and even to fix some parts or something like that. So there are four types actually: pipe vise, pipe cutter, wrenches, and as well scratch all. Okay, so these are the different types. So these then what are the wiring accessories? So these are the to concluding, these are the wiring accessories like switches, lamp holders, socket outlets, ceiling roses, plugs, and flexible cords, distribution board, fuses, as well as cables. So now we will see with some few diagrams. So here you can see this is called as a tumbler switch. So tumbler switch, these are all used in olden days. So so you can see that the switch is projected outside from the wall. Next is flush switch. So fix it with the walls on. Okay, and here you can see normally it will not be projected out. Okay, so similarly pull switches. So it is used for heaters and air conditioners because it will be of high power ratings. Rotary switches, so again it is used for heaters to change the rate of heat, and also insulates the handle to which the blades are fixed, and as well the blades move in steps to make contact with the terminals. Then next is push button switch. So what do you mean by push button switch? So it is used to start the motor actually. So just if you just push the button, the motor will be started. Then next is ironclad switch. So for example, for high ratings, we'll be using this ironclad switch. Normally the fuses will be connected as well as circuit breakers will be there. The next is knife switch. So this is called as a knife switch, which is used to change the loads, okay, which is used to change the loads. So here for example, if I want to change the load from one to the other load, so I can this knife switch is used, okay. The next is two-way switch. As we have discussed earlier, it will be used in our bedrooms or even staircase, everything, okay. So because at the entrance we need one switch, and at the near to the load we need one switch. So this is the advantage of the two-way switch. So we can operate two different switches independently. So these are the different lamp holders. So you can, I already have told, this is called the patent holder, batten holder, and screw lamp holder, and as well fluorescent lamp holder. Then starter holder, ceiling rose is there, and mounting blocks is there, socket outlet is there. So wiring materials are also there, plug point, plug adapter, main switch is there, power indicator is there. Okay, so this is the distribution fuse board, this is the electrical fuse board, and all those things. So anyway, we have completed the wiring and accessories. So now we will move on with the cables. Okay, so what are the different types of cables that are used in our electrical engineering? So there are many types. So so you can see that based on conductors, we will be classifying it as single core cable or multi core cable. So single core cable are normally used for less power ratings, whereas multi-core cable will be used for high power ratings. And similarly, on the basis of voltage rating also, we have different types of cables. One is the 250 by 440 volt cable, the other one is the 650 bar 1100 volts cable. So okay, on the basis of conductors used, so we have copper conductors, and then we have aluminum conductors. So then based on the insulation, so based on insulation, we classify it as VIR insulated cable, TRS cable, lead see-through cables, PVC cables, weatherproof cables, flexible cord cables, and XLPE cables. So these are the different types of cables that are used based on insulation. Okay, so each and every cable type based on insulation is having its own characteristics, and based on its rating, we will be using different types of cable according to our requirements. Okay, so these are the different diagrams for the. So here you can use the, as you can see, the multi-core cable, and these are the different types of cable. And next is types of wiring. So what are the different types of wiring? So here we will be having the main different types are the one is the cleat wiring, the other one is the wooden casing, and the TRS wiring, and next is conduit wiring. So what do you mean by cleat wiring? So these are all used in very earlier days. So in this system, you know, the VIR conductors are supported in the porcelain cleats. Okay, so these are normally not used nowadays actually. Then these are again this wooden casing is also not used nowadays. So these are all used in earlier days, and it is also used in only in the residential building in early days. So it consists of the rectangular wooden blocks and called as casting. Okay, so it is made up of from first class seasoned teak wood, and it has usually two grooves into which the wires are laid, and the casing at the top is covered by means of capping, which is a rectangular strip of wood of the same width as that of the casing, and is screwed to it, and 2 or 3 wires of same polarity may be run in one groove. So but the wires of opposite polarity need not be run in one groove. So next is TRS. So TRS is nothing but the tough rubber sheath wiring, and the cable is quite flexible, and it resists rough usage, moisture, climate variations. And so TRS cables may run into the surface of walls, and also it can be buried in the plaster. So this is also used nowadays in few residential buildings. Next is conduit, which is now used widely. So in this type of wiring, VIR conductors run in the metallic tubes called as conduits. So it is the best system of wiring, and it provides high mechanical protection, safety against fire and shock, and as well earthing is also better, and this is the most durable for workshops and also public buildings, and nowadays also implemented in the residential buildings. So you can see that wiring. So what are the points to be considered? So initial cost, it should be economical. Durability should be good. So because it has to withstand the wear and tear due to weather, and as well the safety from fire should be good. Okay, so this is a very important thing in order to have a good protection. Mechanical protection also should be good, okay, and also the wiring should not be affected by the weathers and fumes and dampness and chemicals, etc., and it should have an aesthetic look. Okay, from the architectural point of view, it should have a good appearance, which is also very important, and as well the accessibility. So it should be easily accessible, and life should be good, and maintenance costs also should be good. So these are the different points to be considered while selecting the wiring. So again we will discuss with some few diagrams. So as we have already discussed, that is we will be having different types of wiring, like layered wiring system, wooden casing, and tough rubber sheath, that is TRS, and lead sheath wiring system, and conduit wiring system, which is the most advanced system which we are using nowadays. Okay. So in cleared wiring system, the conductors are supported by the porcelain clay. So here you can see the diagram, and also it's very cheap and can be done easily, and it is it has a base and cap, and its life is very less, and so that it is not suggested for the permanent wiring. And types on it is having 1 and 2 or 3 grooves, okay, at the receiving one, and it is normally used earlier in industries and workshops for temporary wiring. It can be used. And for example, and also the main points to be remembered is the distance between the clads is around 30 centimeter to 60 centimeter. The wires should not run near water or gas pipes, which is very important, otherwise the wood will be easily damaged. Okay, so next is wooden casing capping wiring system. So it is very costly actually, and it is commonly, earlier it was used in residential buildings. So the castings are made of seasoned teak wood, and the casing are covered rectangular strips of wood of same width, known as capping, and it is screwed to it actually. So here you can see the diagram. So you can, from the diagram itself you can understand, and it is available in 3 meters to 6 meters length. And the main points to be remembered is white ants are more attractive to this type of wood, so we have to avoid the white ants, and maybe the seasoned wood can be used, and the casing should also be properly fixed on the wall. Okay, so tough rubber, so this is the next type of wiring, that is tough rubber sheath. There is TRS wiring. So here we will be using PVC or TRS or CTS cables can be used, and the cables are placed on the wooden batten, and battens are then clipped, and then it is screwed, and also it is at a distance of about 6 centimeter to 15 centimeter as it will be laid out. Okay. So next is lead sheathed wiring system. So here it is also called as the TRS system, and the cable is nothing but lead sheathed cable, and as already we have discussed, it has longer life, but it is quite costly, and it avoids mechanical injury when it is properly molded, and the earthing also is very good here. Okay. So surface conduit wiring. So here you can see that we will be using the, so here the diagrams are there. So from this diagram you can see that the PVC or GI contacts are used on the surface of the ceiling, and these conduits are attached to the walls with a hole, with 2-hole strap and base strip at regular distances, and the electric wires are laid inside the conduit. So this is called a surface conduit wiring. So this is what we normally we have seen in our office and other structures. And next is concealed conduit wiring. So you can see that inside the wall, if it is made, the wiring is made, this is the most frequently adopted in present day buildings. So that is, the conduit pipe are placed inside the brick. Okay, so the wall is later completely plastered, and then it is painted. So the electric wires are laid inside the conduits, and this type of wiring are aesthetic. Okay, since there is no electrical wires are seen on the top of the wall. So this is the main advantage of this. So now we will discuss about the wiring layout of the residential building. So you can see, so here I have given some diagrams. So this is the diagram for the wiring layout. So here you can see, so it has been given, and supply is taken from the overhead transmission line through the surface mains, and it goes to the energy meter, and then to the main switch, and then to the distribution board, and the required number of lamp points, fan points, and plug points, and the power points, and as well plug points power plug points, and the neutral wire then runs throughout the installation. The mains is then ironclad double pole with fuse in live line with limit in the neutral. Okay, so these are the different things which we have to take into consideration. What are the ratings of wiring materials that are used? So they normally will be using, for example, switches. You can see that 6 amps and 240 volts can be used, or 16 amps and 240 volt can be used. Okay, so this is for power loads. As well, socket 6 amps and 240 volt and 2 pin or 3 pin can be used, and for 16 amps we will be using 3 pin only, and it will be half rating of 240 volt. Ceiling roses, again it can be 6 amps and 240 volt and 2 plate, and plugs it will be using 6 amps and 2 pin and or 3 pin, and as well 16 amps is 3 pin. And distribution box 16 amps and 240 volt and one way switch can be used, whereas 16 amps and 240 volt and two way switches can also be used. So this is the wiring layout. So here you can see that this is the entrance, and this is the study room, and here you can see that some passage is there, and hall is there, and kitchen is there. So here you can see the different plug points, how we can place the plug points and how we can place the lamps. Okay, and here you can see the dining room is there, hall is there, and this is again a small room is there. Okay, so like that we can arrange. So in each and every room you can see that switches are there, as well the plug points are also there, and hall you can see that a small hall is there, and TV, some small provision has been given, and small passage is also there. Okay, so like that we can design the house wiring in our own way. Okay, and in outside also you can see some plug points can be given in order to connect the external loads, and these are the different things we have to consider while doing the house wiring. So next we will look into grounding. Okay, so what are the different types of grounding or earthing? Okay, so grounding and earthing, and we can go ahead. Okay, so what do you mean by earthing? So earthing means you can see that we are going to connect to a mass of earth. So as you know that earth is nothing but it is a huge number of millions and millions of electrons are there. So whenever you connect the neutral point to there, so it will be having the low resistance, and the electricity will be passing directly to the earth instead of passing through us. Okay, so this is the main advantage of earthing actually. So it will be directly connected to the so whatever so for example, if there is any fault, okay, so and if any person is going and touching that particular equipment or something like that, the heavy shock will be there. In order to avoid that, we will be doing the earthing of the metal parts in that particular equipment, so that whatever electrons that are flowing inside it will not pass through us, it will be directly to the earth. So we will not be observing the shock if earthing is properly done. So why it is done is to ensure that all the times immediate and safe discharge of electric current, and also due to leakages and faults, it should not affect us. So the metallic parts of every installation, such as conduit, metallic sheets and armoring cables, everything, instruments, household appliances, regulators, and everything to be earthed using the continuous bus. Okay, so using a bare wire, it's also called as bare wire. If one earth bus for the entire installation is found impracticable, then more than one earthing system can also be used. Okay, so the equipments and appliances shall be divided into subgroups and then connected to the different earth buses. The earthing conductors, when taken outdoors to the earthing point, shall be encased in the pipe securely, supported and continued up to the point not less than 3.3 meter more below the ground level. So here and before the electric supply lines or apparatus are energized, all the earthing system to be tested for the electrical resistance to ensure the safe efficient earthing. So okay, so it shall be more than 2 ohms, so including the ohmic value of the earth electrode. So the earthing should be that is should not be more than 2 ohms. Should not be more than 2 ohms. Only if it is less than 2 ohms, then whatever the earthing is proper. Okay, please understand, it should be. So this is a very important thing you want to understand. The earthing should be less than 2 ohms. Okay. Then earthing through, there are different types, as you know. So earthing through GI pipe. So in this method, the GI pipe is used as the earth electrode. The size of the pipe depends upon the current to be carried and the type of soil in which the earth electrode is buried. So for ordinary soils, the length of the GI pipe used as earth electrode will be of around 2 meter long and 38 millimeter in diameter. and 51 millimeter, or else it can be 1.37 meter long and 51 millimeter in diameter. So these are all some standards which we use. So for dry and for example rocky soils, the length may be increased to about 2.75 meter and 1.85 meters respectively. So the pipe is placed vertically, burying to the depth and less than 2 meters in the moist as a place as possible. Okay, so preferably in close proximity of the water tap. So water should be always there. Okay, at least 6.6 meter away from the all the building foundations. So earthing through plate. So again here also a GI pipe is used as an earth electrode. If the GI pipe used is of dimension of about 0.3 meter into 0.3 meter and 6.35 millimeter thick, and if the copper plate is used, it shall be of dimensions of 0.3 meter into 0.3 meter and 3.2 millimeter thick. So this is the dimension which we used for the through plate. So the plate is buried to a depth of not less than 2 meter in moist place in the close proximity to the water tap or water pipe, and the plate shall be completely covered by 80 millimeter of charcoal should be used here, with a layer of common salt also should be of 30 millimeter all around it. So keeping it. Okay, so these are the different things. And what are the different types, what are the different types? So for example, different types of materials. One is conductor, insulator and grounding. So here substances that are such as metals that have little resistance to electricity are called as conductors. Substances such as dry wood, rubber and glass and bakelite which have high resistance to electricity are called as insulators. And grounding is nothing but a conductive connection to earth which acts as the protective measure. Then what are the different types of electrical hazards actually? So what are the different types of electrical hazards? So you can see that if there are any electrical accidents occur, you can see that a wound, so this wound will be highly inflammatory to us, so we have to be very cautious. So this has to be taken. So or you can see that heavy fire may be there, entire building will be under fire if proper electrical wiring is not done. So what do you mean by earthing? So all the people living or working in residential, commercial and industrial, particularly the operators and personnel who are in close operation and contact with the electrical systems and machineries, should essentially be protected against the electrification. So to achieve this protection, earthing system of an installation is designed and installed according to the standard requirements. So what is earthing? The process of connecting the metallic bodies of all the electrical apparatus and equipments to huge mass of earth by wire having negligible resistance is called earthing. So the negligible resistance is nothing but it should be less than 2 ohms. So only then, so as you all know that earthing, our earth is a huge source of electrons. So once if you connect the wire to the earth, okay, so whatever the electrons that are flowing due to the faults, it will be directed towards the earth itself, because earth will be always absorbing all the electrons, and because of which the electricity will not be passing through us and we can be safe. So the purpose of earthing is to save the human life from danger of electrical shock or death by blowing the fuse. So to provide an alternative path for the fault current to flow so as it will not endanger the user. So to protect the buildings, machineries and appliances under the fault conditions, to ensure that all exposed conductive parts do not reach a dangerous potential. And also it provides a safe path to dissipate the lightning as well as the short circuit current, and it also maintains the voltage at any point of the electrical system at known value, so as to prevent the overcurrent and excessive voltage on appliances and equipment. So what are the different types of earthing? So already we have discussed, so now we will be discussing with some live diagrams, so like plate earthing, pipe earthing, rod earthing and strip earthing. So what do you mean by plate earthing? So already we have discussed, so in this type of earthing, a plate or copper of GI is buried into the ground of depth of not less than 3 meter from the ground level. The earth plate is embedded in an alternative layer of coke and salts for minimum thickness of about 15 centimeter. The earth wire, as a copper wire of copper plate earthing and can be securely bolted to the earth plate with the help of bolt nut and washer made of copper. So in case of copper plate earthing or GA and of GA in case of the GA plate earthing. So this is the diagram for the plate earthing. So in plate earthing system, the plate is made up of copper of dimensions of 60 centimeter, okay, and galvanized iron of dimension is buried into the vertical pit. So which is should not less than 3 meters from the ground level, which is very important. So next one is rod earthing. So in this system of earthing, 12.5 millimeter diameter and of solid rods of copper and 16 millimeter diameter of solid rod. And or you can use 25 millimeter GI pipe of length, so which can be 3 meters or driven vertically into the earth. So in order to increase the embedded length of the electrode under the ground, which is sometimes necessary to reduce the earth resistance to the desired value, more than one rod section can also be hammered above one another. So this system of earthing is suitable for the area which are sandy in character. So this system of earthing is very cheap. So this is the diagram of this, and so you can see the diagram. So here we will be using the salt and charcoal, and here the soil is there. So the water pipe is there, and okay. So this is called as a pipe earthing. The next type of earthing is pipe earthing. So you can see that the pipe earthing is the best form of earthing, and it is cheap, and also is the system of earthing of GI pipe of 38 millimeter diameter and 2 meters length is embedded vertically into the ground to work as earth electrode. But the depth depends upon the soil conditions. There is no hard and fast rules for this. So, but the wire is embedded up to the wet soil. The earth wire are fastened to top section of the pipe with nut and bolts. So the pit area around the GI pipe filled with salt and coal mixture for improving the soil conditions and efficient to improve the efficiency of the earthing system. So it can take heavy leakage current for same electrode size in comparison to the plate earthing. The earth wire connection with GI pipes being above the ground level can be checked for carrying out continuously, for example the continuity test, and when desired, while in the plate earthing it is difficult. So next is strip earthing. So in this system of earthing, the strip of electrode of cross section of not less than 25 millimeter into 1.6 millimeter of copper or 25 millimeter into 4 millimeter of GI is buried into the horizontal trenches of depth of 0.5 millimeter alone. So if the round conductor are used, their cross sectional area shall not be smaller than 3 if the copper is used and 6 millimeter into 2 if the GI steel is used. The length of buried conductors shall be sufficient to give the required earth resistance. So it will be less than 1.5 ohms. So it shall, however, be not less than 15 meter. Okay, the electrode shall be widely distributed as possible in a single straight or circular trenches radiating from a point. So this type of earthing is used in rocky soil earth bed because of such plates places. Excavation work of the plate earthing is quite difficult. So in those places we will be where the excavation is quite difficult, we have to go with the strip earthing. So again there are many types of grounding system: TT earthing system, IT earthing system, TNS earthing system, TNCS earthing system, TNCS. So these are all something advanced. Okay, so in electrical installation or electricity supply system, the earthing or grounding system connects the specific parts of the installation with the earth's conductive surface or safety and for the safety and functional purposes. In other words, to connect the metallic parts of electrical machineries and devices to the earth plate or earth electrode through the thick conductor wire for safety purpose is known as earthing or grounding. So what are the safety aspects? I think time is going. Okay. So anyway, I will just finish it off very quickly. Safety aspects in the sense you can see, so these are all the electrical safety. What do you mean by safety? The meaning of term safety is being safe and not being dangerous. So you have to place yourself in a secure position to avoid the slipping or moving backward against the live conductors, and also make habit of being cautious. So in the event of lightning storm, avoid outdoor works in electrical installations. So electrical accidents, so the event that happens unexpectedly and causes damage or injury to the person. So what are the causes of electrical accidents? So lack of knowledge, over confidence of workers, and improper instruction given to the workers, use of low quality materials, unavailability of caution boards on safety tags and danger plates, and working on live parts, unavailability of gloves, rubber mats, etc., working with wet hands, unhooked shirt buttons, sleeves, etc. And habit of wearing chains and bracelets also leads to the electrical accidents. So the main electrical hazard, let's now look into the electrical hazard. So we have to think that that is be safe. So this is the thing which we have to remember. B is nothing but for burns, E is nothing but for electrocution, S is nothing but for shock, A is nothing but for arc flash, and F is nothing but for fire, and E is nothing but for explosion. So these are the different types of electrical hazards that we daily encounter. So you can see that this picture, the electrical hazards. So what do you mean by burn? So most common shock related with injury. So three types of electrical burns are there. One is electrical, arc flash is there, then thermal contact is also there. Then electrical hazards, the next one which we see is electrocution. So it is fatal. So that is, it can kill. Okay, that is can kill due to the electrical shock. So it results when the human is exposed to the high amount of electrical energy. Okay. So next is shock. So body becomes a part of the electrical circuit. Reflex response to the passage of electric current through the body. So you can see that small wound will be there. So these are all the burnings which are occurring to the electrical, that is shock. Okay. So next is arc flash. So arc flash is nothing but sudden increase of electrical energy through the air when the high voltage gap exists and there is a breakdown between the conductors. So it gives off thermal radiation and bright intense light and causes of burns, and it can lead to temperatures of around 35,000 degree Fahrenheit. You can see the 35,000 degree Fahrenheit can be there. So next is electrical hazards. The next in electrical hazards we see wood fire. So most result from problems with the fixed wiring, and problems with the cords, plugs, receptacles and switches also cause electrical fires. The next is explosions. So this occurs when the electricity ignites explosive mixture of materials. So sometimes if there is an explosive material around in the air, then it may result in explosions also. So electricity is the source of these hazards, and all hazards are of equal importance. Lesson focuses on the eliminating these electrical hazards. So you can see, so these are the different things you want to remember. For example, if we have encountered the amps, that is current is, so we will see what will be the magnitude of current and what will be the reaction that is going to take place. For example, if the current is less than 1 milliamps, then it is not perceptible. That is, we will not be a slight, this thing will be there, that's it, and we will not, if the current is less than 1 milliamps, so we will not be able to realize it. If the current is around 1 milliamp, then a faint or tingle will be there. So if the current is around 5 milliamps, a slight shock is felt, okay, and but it is not painful but slightly disturbing, and an average individual can let go, but strong involuntary reactions can lead to other injuries also. So if it is greater than 5 milliamps, that is from 6 milliamps to 25 milliamps, painful shock will be there, or loss of muscular control also will be there. If it is around 9 to 30 milliamps for men, so previously it was for women, so men can quite stronger than women. So they can see that the freezing current will let go a range where individual cannot let go, but can be thrown away from the circuit if extension methods are simulated. So 50 to 150 milliamps, then what will happen is extreme pain will be there, respiratory arrest will be there, severe muscular contractions will be there, death is also possible if it is greater than 50 milliamps. So if it is from 1000 milliamps or 1 amps, okay, you can see that pumping action of the heart will be ceased, and muscular contraction and nerve damage will be there. And if it is around 10 amps, that is 10,000 milliamps, so you can see cardiac arrest will be there, severe burns also will, death is 100% will be there. Okay. So what are the different types of electrical hazards? So you can see that defective equipments are also possible, and you can see that your components will be blasted, and you can see that many firing will be there. So what are the different, so here you can see that these are also different things. Okay, you have to use the proper gauge actually. So you can see that higher the number of gauge, smaller the diameter. Okay, so the number of wire standards depends upon the current carrying capacity. So you can see that if the gauge is less, for example, if it is a 12 gauge wire, it can handle up to 20 amps. If it is a 14 gauge wire, it can handle up to 15 amps. So you can see that as the gauge increases, the amps rating of the wire is also getting increased. So we have to use the proper wiring gauge in order to safeguard us from the electricity. Okay, that's very important. So here you can see that regarding the voltage, so you can see that up to 50 volts, you can see that the clearings distance should be around 10 feet. Okay, so for example, we will be having the overhead transmission line. So in that, we'll be having a different voltage may be passed, or and also most of the circuit boards, many wires will be there. So up to 50 volt, you can see that 10 feet should be given. Over 50 to 200 volts, 15 feet should be given. Over 200 to 350 volt, 20 feet distance should be there. Over 350 to 500, okay, voltage, 25 feet should be there. And over 500 to 750 voltage, it should be 35 feet should be there. Over 750 to 1000 voltage, it should be 45 feet should be there. Over 1000, then there are some standards which has to be given by the registered professional engineer who is qualified person, and it will be strictly with respect to the transmission and distribution authorities. So next is electrical protection methods. So these are all the different things. Underground protection system which are used, that is GFCA is used. Okay, that is ground fault circuit interrupters are used. It is designed to protect the people from the electrical shocks, and it detects the ground faults and interrupts electric currents, and also it limits the duration of the electrical shocks. So there are three types of GFCA, that is the receptacle GFCA, temporary or portable GFCA, circuit breaker GFCA. So what are the prevention of electrical accidents? So you can see that safety training should be given to all persons working on the plants, and only qualified men should be working, and untrained persons should not be allowed to entering into the electrical equipment. While working on the live equipment, the proper instructions has to be followed, and instruction also to be there for the supervision, and visitors and unauthorized persons should not be allowed to handle the electrical equipment. And the work content and work sequence, especially it should ensure all the safety measures, and do not work if you are not sure about the knowledge or condition of the equipment. Do not perform or continue to perform any work when you are in doubt or about the safety procedure to be followed. Insulate yourself on the insulating material like wood, plastic, etc. before starting to work on the mail. Okay. Also well insulated and proper wire of sizes with ISI mark should be used. Always use the proper insulated tools and safety devices during the working. Test rubber gloves and safety equipments. Insulated tools should be used periodically, and we have to avoid use of substandard materials or defective materials. Inspect all the electrical equipment and devices to ensure there is no damage or exposed wires that may cause a fire or shock, and correct rating of the fuse and MCB should be used. So, and also like this many different safety aspects has to be followed, and your hand and feet must be dry. It should never be wet. Okay, very important thing. And while working on the live main, so avoid working on the defective equipment. Always keep safe distance from the HV, and that is high voltage, and do not make safety devices inoperative, and use preventive devices such as ground fault interrupters, etc. So never speak to any person working upon the live mains, and make sure while working on the live that is line, that a capacitor is fully discharged. That is very important, because normally a charged capacitor also will give us a shock. And also we have to avoid working when there is improper illumination, that is very or insufficient light is there. And do not carry a pipe or conduit reinforced umbrellas, other conducting material vertically in the switchyard or live or near the live electrical equipments or conductors. So do not wear suspended necklace, and when using a ladder, it should be properly held firmly by another person, and do not work alone, and do not use two ladders together, and use safety belt, and electrical installation and equipments used in hazards area should be satisfied with as per the specifications and type of protection. So these are the different types of protection. So we have to always replace the old wiring, and avoid cords lying under the carpet. Okay. So these are the different safety signs which we have to be used. So safety signs like electrical safety signs, caution, strong radiation, or electrical gate keep clear, and laser radiation, do not stare, do not lock at the electrical arc. So these are the different safety signs which are used. Okay, so safety signs and symbols used in industries. So you can see that the warning can be placed, so pinch point, or you can see that caution can be placed, and warning, electrical hazard, authorized personnel only. So like this, the electrical safety signs and symbols has to be placed. So danger, so electrical hazard, authorized personnel only. So like this, we have to place different safety signs and symbols inside the industrial premises where heavy current and high voltages are there. Okay. So safety signs and symbols used in industry. So again, these are some danger and electricity. First aid, wherever you keep the first aid, you can just place this green with plus symbol, and first aid kit, again another one symbol is there. So fire extinguishers has to be given some correct safety signs and symbols, because we should not search whenever the fire is there. The fire extinguisher should be placed along with a symbol. So like this, there are many different symbols and used in our industries. Okay. So for grounding, you can see that different types of grounding symbols are used like this. Okay, so you can see this. So then electrical shock. An electrical shock occurs when the person comes into contact with the electrical energy source. Electrical energy flows through the portion of the body, causing a shock. So this may result in the injury or damage of the person, or even it will result in death. So what are the factors affecting the severity of electrical shock? So the magnitude of the voltage of the system, the period of duration for which the area is in contact with the live part, and it also depends upon the supply of the system, whether it is AC or DC, and also the body resistance. If it is a wet, the body resistance will be very less, and because of which the shock will be very high. So shock may occur even when the voltage is low, that is even if it is less than 50 volt or 75 volts. So the path of the current through the body, okay, how it is passing through, it's very important. So based on that, the factors will be deciding the severity of the electrical shock. And also the presence of moisture in the environment also plays a very vital role. The general health of the person also plays a very vital role. And the phase of heart cycle when the shocks occurs, that is also very important. The magnitude of the current passing through the body is also very important. So the current strength, for example, if it is AC of low frequency of 1, okay, so then are just bearable and does not cause any points. So 8 milliamps to 15 milliamps, so already we have discussed, to give a pain shock, and similarly 20 milliamps to 50 milliamps passes through, it may stop the breathing. 50 milliamps to 100 milliamps, it may result in the ventricular cavity of the fibrillation. So 100 milliamps to 200 milliamps, it may cause the fibrillation of the heart, that is, heart may not function. And if it is above 200 milliamps, it will cause death. So above 200 milliamps, 100% it will be leading to death only. So we have to be very cautious of 100 milliamps of current. Okay, so it's above 100 milliamps or above 200 milliamps of current. Okay, so that's all for the magnitude of current. So how to rescue? So this is what how to rescue. So here what are the activities that has to be performed is we have to switch off the supply immediately whenever a person comes in contact with the live conductor, and we have to remove the person from the contact and pushing the we have to push the person with the dry sticks of wood, or pull him using the hands by wearing the insulated hand gloves, and then removing the person from the fire. If the person catches the fire, then wrap him in the blanket or coat and roll them. Okay, and we have to keep the patient's body horizontal, or in any stage always keep the patient's hand low. This patient should be kept horizontal with the head slightly raised to make the breathing easier, and call to the doctor immediately. And before coming to the doctor, if any burns or wounds occur, then the body of the person use proper oil or medicine. If the person is not breathing, immediately start artificial respiration until the medical aid arrives. Do not touch the person with the bare hands. Do not give liquid unit the patient is the conscious. Okay, so don't give any liquid food. Okay, so again it will cause the death, severity of the death will be high. Give the artificial respiration to the person who received the electrical shock by any one of the methods. So there are 3 different methods of giving the artificial respiration. So for example, 4 different types are there. Okay, so you can see that one is a mouth to mouth measure method, Schaeffer's prawn pressure method, Silver's thrust method, and Nielsen arm lift back pressure method. So Schaeffer's prawn pressure method. So what we have, so this is the Schaeffer's prawn method. So you can see that for example, lay the victim on his stomach, okay, with his face on one side, and one arm extended directly overhead, the other arm bent at the elbow, free his neck from clothing, kneel over the victim back, then place both the hands on his back near to the lower ribs. Then step 5, press gradually and slowly and swing forward slowly back for about 2 to 3 seconds, leaning yourself forward with arms held straight. So now relax the pressure slowly and come to the original position for about 2 seconds without lifting your hands from the victim. Repeat the process slowly for 12 to 15 times in a minute till the breathing to the person is restored, and do not give any liquid until the patient is conscious. So here you can see the diagram of how this Schaeffer's prawn pressure method is used. So next is Sylvester method, and this is also called as arm lift pressure method. In this method, the artificial respiration in which the victim is laid on his or her back, and air is expelled from the lungs by pressurizing the arms over the chest, and fresh air is drawn by pulling them above the head. So here this is one more method which is called the Sylvester method. So this is how we want to lay the victim in this position, and we have to do as per the steps which he has discussed. So next is Nelson arms lift back method pressure. So here you can see the diagram. So you have to make his lay down lie in this way, and we have to press on his back like this, okay, and then we have to always lift his elbow in this way, okay. So next is mouth to mouth method. So victim is laid on his back, and remove that there is nothing in the mouth of the victim, and put one hand under the victim. So this is how the artificial respiration works, and shut the nose of the victim, pull your mouth tightly over the mouth of the victim, and then blow vigorously so as to expand the chest of the victim. Remove your mouth, or let the returning air escape. Repeat this process to 3 to 4 seconds, and this method supplies 10 to 12 times more volume of air into the patient's lungs than any other method. Repeat the process slowly 12 to 15 times in a minute till the breathing of the person is restored. Then these are the different things for the energy at high and extra high voltages. For example, 11 kilovolt, 2.57 meter, and ground clearance should be there. Sectional clearance should be 2.6 kilometers between the two wires, two conductors. So 33 kilovolts means it should be the 3.7 meter for the ground clearance, and 2.8 meter for the sectional distance. That 66 kilovolt line, 4 meter ground clearance should be there, and 3 meter sectional clearance should be there. And similarly for voltage of about 132 kilovolt, 4.6 meter of ground clearance should be there, and 3.5 meter of sectional clearance should be there. For 220 kilovolt, 5.5 meter of ground clearance should be there, and 4.3 meter of sectional clearance should be there. And similarly for 400 kilovolt, 8 meter of ground clearance should be there, and 6.5 meter of sectional clearance should be there. So what are the causes of fire due to electrical? So the electrical faults inside the electrical appliances are the most common cause for the electrical fire, and overloading of the cables also may be, and also many devices plugged simultaneously into the circuit also will be resulting into the fire. And majority of the fires are due to because of not choosing the correct rating of the fuse and MCB, and poor joints also will lead to the fire, and also the loose connections may also be leading to the fire. And if the insulation also deteriorates due to the aging, the firing will be there, and ground faults also may lead to the fire, and not testing the electrical safety devices also lead to fire, and as well safety devices sometimes what is made inoperative also lead to fire. And similarly electrical installations and equipments used in hazardous are not satisfied as per the specifications or type of protection, then it will lead to the fire. And similarly the wiring that becomes defective with the passage of time, and if improper maintenance are not there, and faulty electrical installations and old electrical sockets are really unsafe, and proper maintenance is not there, then also lead to the fire. So precautions to be taken. So frequently checking of the electrical cables and wires, appliances, and closely inspect the cords and plugs, and overloading of the cables, and also do not use too many wires, too many devices, and the correct rating of MCBs to be used, and as well the joints of the wiring should be good, and there should not be any loose connection should not be there, and replace of the deteriorated cable should be done at regular intervals. And similarly the ground clearance fault protection should be using the ELCB or earth fault relay. And similarly the testing of electrical safety devices should be there. Do not make any safety devices inoperative. So similarly the electrical installation and equipments used in hazard areas should be satisfied as per the specifications, and replacing the wire the defective types should be there, and maintenance should be done strictly as per the schedule, and replacement of the faulty electrical installation and overheated appliances should be there, and as well the old electrical sockets and unsafe appliances should be there. Okay, so operation of fire extinguishers. So how to operate it? So this is the fire extinguishers. How to operate is, for example, we have to stand 6 to 8 feet away from the fire, and we have to follow 4-step PASS procedure, PASS procedure. If the fire does not begin to go out immediately, leave the area at once. Always be sure that the fire department inspects the fire site. So pull out the safety pin. So this is P. So P for pull out the safety pin from the handle. Aim the extinguisher nozzle at the base of the fire. So always this is very, so we have to base of the fire. So normally we should not aim at the top of the fire. It should be aimed at the base of the fire. So first we have to pull the safety pin, that is P. A is we have to aim at the base of the fire. Then we have to squeeze the handle. Okay, we have to squeeze the handle or lever slowly to discharge the agent, and we have to sweep side to side over the fire until it is expelled. So we have to squeeze and then we have to sweep side to side. Squeeze the handle and we have to sweep side to side until the fire is extinguished. So this is called as a PASS procedure, which is very, very important to handle the. So it is it will be having the carbon dioxide which is filled inside the fire extinguisher tank, and once the pin is removed and once the pin is removed and for example, and if the nozzle is pressed, you can see that the CO2 will be expelled and the fire will be extinguished. Okay, so here you can see what are the different types of extinguisher are. That is, there are normally there are many types. So the first one is dry powder fire extinguisher. Then next carbon dioxide fire extinguisher. So there are different types like water, powder, foam, wet chemical, and carbon dioxide is there. So each and every type is having its own plus and minus. For example, if you take water type, that is you can see that there are different class A, class B, class C, class D, and class F is there. Okay, so you can see that for paper and wood, or if it is for paint and petrol, or for example if it is butane and methane, then class C should be used, and lithium and potassium and class D, and similarly that is flammable metals. Okay, we have to use class D. So for different types of metals we have to use different. So for electrical equipments we have to use only for example this dry powder and CO2. So here the tick mark represents which for example for paper and wood we have to use water based, foam based, dry type based, and CO2 cannot be used, and water chemical based can be used. Similarly if it is a flammable liquid, okay, then we can use foam based, dry powder based, and CO2 based. Similarly if it is flammable gases, then we have to use dry powder only. And similarly if it is flammable metals, then we have to use dry powder only. Similarly for electrical equipments we can use dry powder as well as CO2. And similarly for fat fryers we have to use only wet chemical. Okay, so these from this table we can choose our type of fire extinguisher for different types of appliances or different types of. Okay, so these are all the things which I just want to convey in this video. I hope this video will be very useful for you, and I have covered the maximum things which I can within the stipulated time, and I am sure this video will be you enjoyed this video, and you something you came to know from this video, and I'm really very thankful for your patient listening for this, and please give a thumbs up if you really like this video, and also please subscribe to my channel by supporting if you are really interested in watching my videos. So thank you very much, and thank you.